Great people, welcome to NameTech channel. My name is Nehemiah, and I'm very happy to have you on board. So this one is a full course on pandas, and guys, we are going to begin from the very basics to the advanced of pandas. But guys, before we begin, please subscribe, like, and share the video to your friends if you have not done so. And to the returning subscribers, I really appreciate you very much for your continuous support. So, guys, basically, without further ado, let's begin straight away understanding what is Python and why should we use, basically, Pandas. Not really Python, it's Pandas. Pandas is a submodule. It's a module in Python. So, first of all, Pandas is a Python library used for working with datasets. Datasets are just like the table. The table. So it has function for analyzing, cleaning, exploring, and manipulating data. And if you're taking data science and machine learning, you find out that this one is a very fundamental course that you have to attend to. Now, the name Pandas has a reference to both panel data and Python data analysis. So this one was created by Wes. This one was created by Wes McNee in 2008. But first of all, why should we use pandas? Pandas allow us to analyze big data and make a conclusion based on statistical theories. It can clean messy data sets and make them readable and relevant. And I said here, relevance of data is very important in data science. If you want to analyze data that is clean, and then it will give you the good results. But then now what can pandas do? Why basically that's a very important question. First of all, let's understand what can these pandas do. So the pandas module give you the answer about the data, like is there correlation between two or more columns? What is the average value? What is the maximum value? What is the minimum value? So you can see that the guys are basically this one is very fundamental, and I guess you can always find the reference or the code base of these pandas at this URL github.com/pandas underscore, basically not underscore hyphen dev.pandas. Now if you navigate to this page, guys, let me copy and paste it to another tab, and then here in this section, guys, when you navigate here, you're going to find what you're going to find the the codes for for pandas. GitHub, guys, basically GitHub enables many people to work on the same code base. If you want to contribute here, you can do that. And if you want to check the codes for pandas, you can always find it here. However, let me focus on the video. Now I want to show you guys now how you can install these pandas in your system and how you can use it. Now guys, basically the first and the very best alternative is to use Anaconda. Anaconda is a Python library, especially for those working with data science and machine learning. So this environment usually come with many packages, thousands of packages to be used for machine learning or data science or artificial intelligence. So guys, I always recommend my students to do it to use pandas if they are specializing in data science. However, guys, let me show you how you can install first of all manually. Now before you install pandas, ensure that you have Python in your system. How do we check if you have Python? To check if you have Python, just navigate to your command line tool. You can use PowerShell, you can use command prompt, you can use terminal for the Mac operating system, or Conda for Anaconda, or any other command line tool. Guys, it's just acceptable. And then now in your command line tool, guys, you're going to type what? First of all, to check the Python version, just type in Python, then dash version, and then you're gonna get the version of Python. You can see mine is 3.11. Guys, basically if this one fails, you can try to say py then a dash version, right? version like this, then you'll still get the Python version that you're using. And then guys, basically the other thing guys that you need to have here is the PIP, and that the PIP usually come with what? The PIP usually come basically the Python usually come with a PIP. PIP is a package manager to install Python modules. And first of all guys, let me show you. For example, in some cases you might not have the Python in your system. How do we download it? To download it, just navigate to the Python website, python.org, python.org, and then navigate to the downloads tab. And then in this section, guys, then I select your operating system. Mine is Windows. That's what it has prompted me with to download for Windows. I know yours can be Mac operating system, can be Linux, can be any other operating system. But when you install it, ensure guys that you click all the check boxes that will be prompted there, so that you may install all the required packages. So once you've installed the Python, and it will come with the PIP. So what you need to do next now is to install. First of all, you install this Python, and then now the other thing now is to install these Pandas. So to install Pandas, again go to your command line tool, and then type in what? PIP. Remember I told you PIP is a package manager to install Python modules. PIP PIP install should be install Pandas. We are discussing Pandas, right? And then hit enter, and then it will install for you. Remember for me, I already have it. I always code with Pandas. That's why I had already installed earlier, but for you guys it will install it for you. So once you have installed, and then you're ready to use it. However guys, basically if you don't want to install it manually, then what you want to do is to install the Anaconda. So to install Anaconda, just navigate to Anaconda website, anaconda.com, and then a / downloads, or you can just say anaconda.com, then a / products / distribution, then hit enter. You'll navigate where onto this download page. You can see the URL here is anaconda.com / download. Now you can see in this section, first of all, the first description here is that the first headline here is that it's a free download. That's the good part of it, especially for you, a beginner, to use free stuffs to test. Everything is very, very important. And then you can see here everything you need to get started in data science on your workstation. You can see it's very, very fundamental. Then here it is free distribution install. And then it has thousands of most fundamental data science, machine learning, and artificial intelligence packages. You can see thousands, So you'll not have to install, you'll not have to struggle to install, those packages, external. Like for us, we have wasted a lot of time to install Pandas. However, you can see in these Pandas, it will come with everything. You'll not waste your time. And then the other thing you can see, it manages. You can manage packages in the environment from the desktop application. How awesome! Then it deploy across hardware and software platforms. So guys, basically what you want to do here is now you can code on the cloud, or guys, you can install it on your system. You can use you can install for your operating system. You can see it it is available on Windows, the Mac operating system, and Linux operating system. Now once you have installed and then you have launched the anaconda.navigator, you'll have a file called or basically an application called anaconda.navigator. Ensure that you launch it. And then once you have launched it, then you'll see several programs here. You can see Dataspell, you have cmd.x prompt, you can see you have Jupyter Lab, you have Jupyter Notebook, and then we have PowerShell prompt, Python community, and many others. So guys, you can decide whichever program or notebook that you want to use to code your Pandas or your Python codes. However, if you want to follow along this course, I'll encourage you to use Jupyter notebook because this is what I'm using, but I'm not limiting you. You can use any other notebook. You can use a Visual Studio Code. You can use this IDE. For Python, PyCharm, you can use anything. You can use any text editor, guys. Is just good for this uh, course. Now, for me, I had already launched, but if you want to launch it, you can just click on it and it will launch it. And then once you have launched it, it will take you where? It will take you to your default browser. Now, in your default browser, then it will bring you some files. It will bring you some other files here. Perhaps it can be such stuffs like this. And then you're going to decide where you're going to place your project. Like for me, I'm placing it at the desktop. And want to create a new file, just click here, new, and then I click on these are stuffs, and then it's gonna create it's gonna create, and then here, guess you can change your title from untitled title to your preferred title, like in this case. Once you have renamed, you can begin to import the pandas. It's already in your system, but now to bring it in your notebook to use it, you have to import it with the import keyword. Remember, in small, Python is very much case sensitive, so ensure that you use the correct keywords. And then now to import pandas, and then we have imported the pandas module. But now how can you use it? Now to use it, guys, you can create another variable here for perhaps your data. For example, let me call it data set. Let me just call it anything, like let me just call it data set, then I'm assigning it to this dictionary. I can say the first key, let me call it perhaps names. Let me call it names, and then I separate a key value, a pair with a colon, and then here let me use a list here. You can see basically this dictionary, you can have even the values can be of any data type. So let me use a list here, and perhaps let me say the first guy is Nehemiah. The second one can be, let me say, Wekesa. The third one can be John, or any other name, or your name. And then you separate a parameter if you want to have several, separate an argument with a comma. And then here perhaps let me say ages, right? Let me just say ages. And then let me say Nehemiah. He is what? 19 years old. And then for example, Wekesa can be 30 years of age, and then John can be 25 years of age. Now this one is our data set. Then here you can do it. You can create another variable for pandas. Now let me say perhaps let me just call it data, and then assign it to pandas dot data frame. So be frame data frame, and then here we're gonna pass in what data set, and then to the print function we are printing out data. Remember, guys, you can just use these values directly in this print function, but again, it's a good practice to use variables. It helps a lot. And then what we do here now, let's run and see if it will output the results here at the terminal. And then I guess you can see it has printed out these results. Now the first column, this one is the labels. This one is the header, the name and age. This one is the header. This one is the label, and then this one is our what? This one is our columns now, our data set. So guys, you can see by default it is indexed from 0, 1, 2 to in that order, guys, basically. However, you can change it later. However, let me guys show you an alternative way to use a pandas. To use pandas, you can as well use it as an alias. alias is another name of something. It's a nickname of something. Like for example, you can say Pandas A as a PD alias. Like I always like to use this example. For example, I'm Nehemiah Wekesa. Now the alias or the nickname can be nametake. So nametake, it still refers to Nehemiah Wekesa, but in that case, if you want to use that nickname in Pandas, you have to add in the AS keyword to use it as an alias or the nickname of Pandas. You can use another name, but a PD is a default one for Pandas. But if you use any other one, it will work. Now, so let me just copy this course and I use uh, exactly the way it is. Let me paste it here. But then now here I'm using what PD now because I've changed. I'm using it as an alias. Then when I run, you can see it still outputs the same results. So how do we check the version of Pandas? To check the version, we do what we import first of all Pandas. Let me use it as a PD alias PD. And then here, what I do, let me say print PD. Now we're using it as an alias, then two underscores, then a version, then a close into underscore versions, and then when you run it, you'll get the version of pandas that you have. So guys, basically this is how you can check the version. And now I want us to begin with the series, the pandas series. A pandas series is like a column in a table. It's a one-dimensional array holding data of any type. It can be an integer, string, or anything else, guys. So what we do here, first of all, let me copy this first line of code. I don't have to retype it again. And then here, let me create a variable. Guys, it's a good practice to use descriptive name to declare your variable or to create your variables. However, for the sake of tutorial, I want to make the video short, so I'm trying to use shortest name. And then here, let me add in some data. You can use anything. This one is a one-dimensional array or a list or just a basic Python list. And then here, what I do, let me create now the variable for the pandas. Let me assign it to pd dot series. Now series is a function inside the pandas module. Let me we are passing a now, the variable a, and then or just let me just call it I say that it's a good practice to use descriptive name. Let me just call it my list using I'm using snake case, so let me just pass here my list like this. And then what I do here, the print function, let me say print data. And then what I do, let me run and see if it will work. Guys, you can see it does. It has created a panda series from this list. Now series, I said, is like a column. This column just like a column, and it has default labels. One is labeled 0. Remember, indexing in pandas, just like in numpy, begins from 0. 0 is like 1, 1 is like 2, 2 is like 3 in that hierarchy. So you can as well specify. You can as well choose to return basically the first index, the last index, or whichever index that you want to return with the basically with the values, actually with the values that you want to return by specifying the index number that you want. For example, if you don't want to return everything, like in this case, we have returned what we have returned the entire values of that list, of that series. However, if you want to return some values, for example, if I want to return index 0, index 1, basically this one is just say what 0 to return what? It will return 1. If I want to return this 65, remember this one, this 0, 1, 2, 3, 4, 5, 6. Remember indexing is beginning from 0. So this one is 0, 0, 1, 1, 2, 3, 4, 5. Now if you say 5, it will return what 65. So it can, find that value there, and it returns 65. So you can as well, guys, create for yourself your own labels. You can see by default um, it is given from 0, 0, 1, 2, 3, 4, 5 to infinity. However, you can do it, you can specify your labels. For example, guys, if you want to specify your labels, first of all, separate a comma. Then here you add in this parameter called index, and then you specify how many values are here. There are 5, right? So you can say you can pass it through a list, and then perhaps let's say the first one, let's call it A, and then the second one we can call it B, the third one we can call it C, the fourth one not really should be a string, C, then the fourth one can be D. How many are they? 1, 2, 3, 4, 5, 6. So the fifth one can be E, then the sixth one can be F. Here there are 6, right? Sure. So now when we run, guys, it will be indexed A, B, C, D, E, F, and you can see. So guys, basically this is how you can do that, and basically you can do the same. You can return some specific values, or you can specify any index here. For example, if you want to specify F, it will return what 65. So let's say instead of last time we used 5, but this one we use F, it will do what it will still it will still, so it should be a string, right? It should be a string, F. Then let me run and see. You can see it still returns 65. So guys, basically this is how you can do it. This is how you can create your own labels. So now guys, this one is very, very important, and I think you've understood. Perhaps you can see I've used the key value pairs here in this dictionary. So let me talk about the key value object is a series. So you can also use key value objects like a dictionary when creating the series, like how we did it here, and I saw it created for us the list. So alright guys, let me just show you again so that you may understand every concept here. So in this new cell, let me say import pandas is what pd alias. Then here perhaps let me use the calories. I like using calories, and then here let me say calories. These are what? These are the energy in your body, or yeah, basically these are the energy in our body. So here, for example, let me say, for example, day one, perhaps day one, the calorie, this is the key. Then the value can be, for example, the calorie in day one was perhaps, let's say, for 20. Then day two, interesting. Day two, I can call it what? Basically, I can give it a value of about 380, and then day three, I can give it 390, and then here let me create another variable for our pandas data. So let me say for our pandas series, let me call it data, and then assign it to the pd. Now we use it as an alias, pd.series, and then here we're gonna pass in what? Calories, and then here the print function, let's say print, and then we are passing what data, right, or any other variable that you gave it there on your end. Then when we run, And then again, so basically you can see we have done what we have created this panda series from this, just basic dictionary here. So remember guys, basically the keys of the dictionary can also become what they can also become the just like the labels. Like in the other case, we were defining A, B, C, D, but now the keys can be what can be, you know, can be what can be like the labels. You see. So and so guys, basically you can do it. You can create basically a series using only data from some specific, days. In this case, we have used to day 3. However, guys, you can specify the index that you want to return. For example, if you want to return index from the day 2 or day 1 to day 2, you can just do the same like what we did there last time. You specify first of all, not here. Here, guys, basically you specify the values that you want to return by specifying the index. For example, if you want to return index 2, 1 and 2, you just specify. So let me see, perhaps day 1 is a string, will be day 1. First of all, let me use this one first of all, and then I run. And then you can see it has brought the data for the 1 alone. And so this is how you can do that. But let me talk about the data frames so that you may understand much better. Now, dataset is a panda. Basically, datasets in pandas are usually multi-dimensional tables called the data frames. So a series like a column, and then a data frame is the whole table. The whole table. And so, how do we create data from two series? So to create a data frame, it's like what we did here. Where were we? Where did we do that? Here, guys. Let me just copy the same, and then let me just paste it here, and then guys, basically this is how you can create the you can create your data frame. So you just define basically from a dictionary. You can see we have the keys and the values, and we assigned the values for each key. And then when we, for example, let's change the value here, then perhaps let me just call it df for a data frame, then a df, then when I run, it still outputs these results. So we shall talk about this data frame as we go on, but let me talk about, alright guys, so let me just talk about these data frames in detail. First of all, let's understand what is data frame. Again, Pandas data frame is a two-dimensional data structure, like a two-dimensional array or a table with rows and and a column. And guys, this one was an example of a data frame, and you saw it outputs these results. Just we use here symbol, just Python dictionary, and it output the results. So you can also locate a row. Basically, guys, as you can see from these results, the data frame is like a table, just like a table with the rows and columns. So pandas uses the lock attribute to return one or more specified rows. How do we do that? Here the print function, you can do it. You can add in this parameter dot lock, then you specify the row that you want to return. So for example, if I want to return row 1 that has Nehemiah and at the edge, what I do, just let me just hit give it 0. That is index 1. Remember, indexing begins from where? From 0. 0 is like 1, 1 is like 2. And then again, so basically you can see it as given us the results here, the names in the edge. So guys, basically this is how you can obtain such results. So guys, basically you can see it has returned a pandas as a basically as a series. So guys, basically remember when using these square brackets, the results is a pandas data frame. When you use these you know squared brackets here, so the results will be what? The results will be data frame. But guys, basically let me talk about something. Yes, let me talk about how you can name your basically how you can name your indices. So the indices argument, you can name your own indices like guys, let me just once again let me just repeat again, because it's a good practice to code all the time so that to practice our coding skills. So let me say import pandas is what is a pd alias, and then here let's create our data, and then let me just use a normal Python dictionary here, or a JSON file. I'm using just a normal Python dictionary. Then here let me just say call it calories. Calories, I told you that this is the energy in our body. When you work out, it got burned, and it can reduce. And for example, day one, this guy will had 420, right? Let me just give it a list. Perhaps let me call it, give it any value like let me call it even 500. And then day two, I think he worked out. Then it got to three. Let me just give it 400. Then day day four, he got or she got. Let me give it 300. So you can see the importance of workout. It helps a lot. You can see the energy is burned here, and this guy can be healthy. So now let me take say the duration of the workout. Duration. So for day one, let me call it. Let me give it what? Let me give it even 50, perhaps 40, that any other value, just guess it. And then here, where? Here the print function. Let me print out. Let me create what? Let me create a data frame. Let me just use a variable df, then a pd dot data frame. Pd dot should be data frame, right? Data frame. And then here I'm passing that variable for data and then I want to add the indices, because if you run this one, it will be indexed from 0, 1, 2, 3, but I want to give my own indices. So in that case, I have to add in this parameter called index, and then I'm gonna assign it to this list of index numbers. So for example, let me call it day 1. Let me call it another one day 2. Let me call another day. It should be a string, right? Day 3. Then the print function, let me say what? Let me say print what? df, our data frame. Then what I do, let me run and see if it will give us the indices. You can see now it is day 1, day 2, day 3. Day 1, the calorie was 500. The duration of the workout was 50. And then day 2, you can see its value. So guys, basically this is how you can do it. This is how you can add a list of names, to give each row a name. Just very awesome. So guys, basically also you can do it. You can locate the name of the index. For example, if you want to return index whatever, you can do it. You can use the lock attribute to return the specified row. Like for example, if I want to return this row 3, day 3, basically what I'll do, I'll just add in this parameter called, or attribute called should be lock, and then here I'm passing what I'm passing day 3, right? Let me call it day 3. Then when I run, it will output the column 4, basically the row 3, which the color is 300. You can see it is 300, and then the duration here is it is 30. So guys, basically this is how you can locate your index. So guys, basically I want to show you also how you can load your dataset stored in a file, externally from basically inside your system. So Pandas also allows you to load them into your data frame. Let me show you. For example, let's begin with a comma separated file or a CSV file in a data frame. So first of all, I have this data. First of all, let me get. I have this data I just pulled from the internet, the employee sample data .csv. Ensure that it has this extension .csv or a comma separated comma separated file or a value. So what I do is here to load it. What I do here, let me just first of all import pandas. Import pandas is a pd alias. Now guys, basically if you want to import it directly, a good practice is to ensure that you have these files in the specified folder. Like for example, it is where we place it at the desktop, right? Let me just paste it here, and then perhaps let me use a shorter name that I can use it quickly. Perhaps let me just call it data. And then guys, basically if I want to return this exact if I want to read this value or to load it, you can do it. You can say, for example, let's create our data frame variable df, then let me say assign it to a pd, the alias for pandas, then should be dot read underscore csv comma separated file, and then here I'm gonna pass in what data .csv file, and then here when I run, let me say for example print print the df data frame, then I guess it will return what that data frame. Let me try to run and see if it will work. So guys, basically let me check it out. You can see, let's find the error. In position start byte. So I think there's an error somewhere, right? I think there's an error. First of all, let's check it out. Read underscore csv. So guys, I think it can't read the data. So I think that this data contains some values which are not readable. Perhaps it might have. Let me check it out. I don't know the problem. I think it has the values which can be read. Let me just create another. Let me just create another CSV file. So what I do here, let me get there, and then let me go to the spreadsheet, and then what I do here, let me create just data. Let me just create some more data here. Perhaps let me just copy these values here, and then I do it. Let me just paste it here, and then what I do, let me save here the desktop, at the desktop, right? Then here perhaps I can call it, let me just call it data 2, and let me just call it dat. Then let me check it out if I have it there. Dat, no, it's here, but I guess I wanted to save it as a CSV file. You can see this one is xlx. So what I do, I have to modify it. It must be a CSV file, comma separated file. So what I do, let me just save it as, and then here I'm gonna change here from CSV from basically. Let me first of all change DAT, and then here I'm gonna change here to Microsoft, from Microsoft Excel workbook. I'm gonna change it to basically to CSV. Where CSV, I think it's this one. Yeah, this one, comma separated file. So what I do, let me save, and then what I do is let me now try to run it and see if it will work. It was DAT, right? Let me run. Yeah, so as you can see, it has printed out. I think the other file, it had the issues. It had perhaps some files which are not readable. Perhaps it were binary values. However, guys, you can see it has read out these files. It is dat.csv, and guys, you can see it has done what it has read. It has read this, a file here. So guys, basically a simple way to bring to store big data sets is to use the CSV file or a comma separated file. So basically, CSV contains plain text, and it is a well-known format that can be read by everyone, including even pandas can read it. And so, guys, I want to use here another example, another data. I have another data, guys, that I've already created. But so guys, before I show you that, for example, if your file is in a different directory, so basically what you have to do is to specify the file directory. If it's not at the same file directory, you can see here the desktop. You have this dat.csv, basically data.csv. That's why it has been easy for us to to open it. But for example, if it is in a different directory, like I have another data here, the download section, you can see it is data.csv, and it has some other values in it. You can see it has duration, pulse, and whatever. So guys, basically how can we read these values here? So for example, if I can see this data is cleaned, it can be read by pandas. However, when I just try to add in what data, it will not read. Or basically what I do, let me just delete first of all this data. You can see there's already data.csv at the desktop. However, also here first of all, let me click on OK. Guys, basically here at the downloads. At the downloads, you have data.csv, but at the where. So let me return home here. Here at the where, the desktop, I don't have data. Oh, here it is. Let me just delete here the desktop and data.csv. So let me delete, and then basically an error occurred, right? Basically an error occurred. However, guys, basically when I try to run this, let me just delete it on this other end. Let me just delete from the desktop directly. Let me just delete here. It is, or let me just delete everything. These are CSV files. It's already, basically the reason why it failed to be deleted, it is because it's opened here. It's already opened. That's why it failed to delete. Let me just try again. And then you can see now they are deleted, right? So also when I get here, you can see there are no those values here. So when I try to read this value, you can see it is available here, the downloads. And the downloads, there's a file called data.csv. However, when I try to run it here, it will not work. It will say that this file is no longer available here. So you can see here no such file or a directory, data.csv. So guys, in this case, you have to specify the directory that you want to that your file is. So in that case, guys, the easiest way to get the directory, go to your file and then ensure that this tab is opened. It might be closed on your Windows operating system. I don't know on Mac. However, ensure that you open it Then what you do, select the file that you want to copy the path, and then I click here, there's an option to copy the path. And then now what you do, go back to go back to your codes, go back to your codes. Then now here, instead of just CSV, the file name, what you do, um, you copy the entire file path here. However, here you have to specify two backslashes, a pair of backslash, also here a pair of backslash, and then also here a pair of backslash for it to work, and then also here a pair of backslash, and then when you run, then this one will work out. You can see it has worked out because we have specified the file path. So guys, basically remember, if the file is in a different directory, you have to specify the full path. But if it is in the same directory where your Python files are, then you can just give it the name. But if it's a string, it must be enclosed inside the quotes. You can see it at post the results. It has printed out the first 5 rows, and then at the last 5 rows. So so guys, basically you can see this is how you can do it. This is how you can this is how you can read these files. So now guys, basically how do we load it into our data frame? So to load it, to load the CSV into a data frame, you can also do this. You can also say to underscore string method. Then guys, it will still gives you these results. You can see it has loaded out this entire value here. You can see just printed out the entire everything. But guys, if you don't specify this property here, this method, it will print the first 5, and the first 5 rows, and the last 5 rows. So basically, we should use this to underscore string method to print the entire data frame. So guys, basically if you have a large data frame, basically with many rows, Pandas will only return the first 5 rows. If you don't specify what this method here, it will just do it. It will just return the first 5 and the last 5. You can see the first 5, then at the last 5 rows. However, you can see here at the end of the description here, we have 169 rows, and then the columns are 4. So basically this is how you can do that. So guys, basically let me talk about the max underscore rows. So basically the number of rows returned is defined in Pandas options setting. So you can check basically your system's maximum rows with the pandas.options.display. Let me just show you that, guys, so that I want you to understand every concept in Pandas, so that you can improve what your data science career or a machine learning career. So let's say print, and then here I'm gonna do this. Let me say PD. If you want to check the maximum row, basically to check your system's maximum rows, you do this. You have to add in these settings here, or parameters, pd dot options dot display, and then a dot max underscore rows should be rows. And then what I do, let me run again and see if it will work. You can see it is 60. Mine is 60. So I don't know on your end is what, but in my system the number is 60, which means that if the data frame contains more than 60 rows, the print df statement will return only the first 5, and at the last you can see this one surpassed 60. That's why it printed out the first 5 and at the last 5. So even if yours surpasses, if you are what, if your system now basically if your system number is more than this one, then it will not return the first 5, and the last 5 it will return everything. However, because mine is limited to 60, it will return the first 5 and then the last 5 the last 5 uh, rows. But again, you can also change the maximum rows number with the same statement. So guys, basically in that case you can say what you can say. You can let me just show you that, guys. Let me just use this code here. Let me just use this code here, guys. What I do here, let me just say and in this parameter pd, let me just copy this line, then here let me paste, and then what I do here, let me assign it to the values that I want. Perhaps let me say 1000. And then guys, basically in this case when I run, it will not print out the first 5 and the last 5. It will return everything. And then guys, you can see it has returned everything, because the values that I've set, it is more than the numbers of the number of rows in this in this data set, in data frame. So guys, basically that's how you can change the the values. So guys, I want us to discuss how to read the files with JSON, or to read the data frames with JSON. Now we've been talking about the CSV file, the comma separated files. However, I want us to talk about the JSON, because the big data sets are often stored or extracted as JSON. JSON is a plain text but has the format of an object, and is well known in the world of programming, including these pandas. So in our example, guys, I have a file called I've already created a file for JSON. I've just called it data.json. So let me show you that. In the downloads, I have this file called data.json. So how can you create these files? So in your notebook, let me just use a simple one like notepad. You can just give it something like first of all, you create your data, but like let me just copy. Let me just open this one. Let me open with you can open it this data. Let me just find something that I can open the data from. I want to copy the codes. Let me copy the codes here. So basically, remember this one is in a format of like just like a dictionary, like this one. So you just copy the data, and then you do it. Let me just copy here. Basically, I just want to show you how you can create your your JSON files. So you have the data now, and then now to save it as a JSON file, you have to save it as for example, let me call it my JSON. Let me say my JSON dot JSON, JSON, and then again, so basically in that case, you have changed from txt document. You can change it to all files. So it will be my JSON.json. So let me save, and then so now guys, basically I want to export this file to the desktop. I want it to be at the same directory. However, I'll show you how you can open it from a different directory. So let me just place it here at the desktop. Basically, post that basically pasting the data into the JSON here at the desktop. Basically, so I have data.json. I want to show you how you can read it. So what I do here is, first of all, let me show you how you can load the JSON file into our data frame. So what you do is, first of all, import pandas is what pd alias, and then here. So guys, basically most of the time you'll be using JSON, because if you have a very huge number of data sets, then a JSON is for you. You have to use JSON, files. So here let's say data, basically data frame, then let me assign it to pd dot, first of all, read underscore, Now here we are not reading CSV, it is now JSON. The file name changed to JSON. Then here you have to specify it is JSON, basically data dot JSON. You can confirm the name, ensure that the name tallies with or basically matches the what is here, the your file directory. You can see it is data.json, exactly as what we used here. Because it's a string, you have to use the quotes. Now how do we load it? To print it out, let's say print df. So you can see it has returned what this data here, these are data sets. But if it were to fail, you should have used this argument here called to should be to underscore string. I wanted it to fail so that I can show you, but I don't know what's the problem there. However, I remember I changed the maximum number to be returned. I changed it to 1000. So oh sure guys, basically here it should be dot, not underscore, should be dot. Then it will return everything. So guys, let me talk about dictionaries as a JSON. Dictionary is a JSON. So JSON objects have the same format as a Python dictionary, and as you saw that it was somewhere here. You saw it was in a format of like just like the Python dictionary. So if you basically if your JSON code is not in a file but in a Python dictionary, you can load it into the data frame. So like guys, let me just do this. Let me open that JSON file. Where was it? I want to copy the data. Let me just open it. Then what I do, let me just copy the data. Then let me I think is there a need for me to close? No, let it remain the way it is, or let me just minimize. However, guys, basically I want to use this I want to load it as a just like a Python dictionary here. So what I do here guys, let me say import pandas. Remember guys, that this import you can just import in the first cell, you can use it in the entire cells. However, I'm repeating myself. I want you to understand every concept. I want you to understand where these modules should be imported before you use it. But you can as well import it here at the top, then I use it at the bottom without having to repeat yourself. However, let me just import pandas. Remember this Jupyter notebook, even if you have several cells, it's just a single document. It's just a single document. But now the goodness with the cells, you can render each files or a specific code snippets from different location. You can run from different segments. However, just a single file. When you import it somewhere here at the top, it is the same when you can as well use it here at the bottom. But I'm repeating so that you may understand every concept here. So is a PDLS, and then here let me create a data and then let me assign it to this dictionary. This is a Python dictionary. Basically this is a JSON file here. I've just copied from the other side from from that JSON file. Now I've imported it just like a normal Python dictionary. So what I do guys, here let me just say print df. First of all, let me create the variable for our data frame, then let me assign it to pd dot data frame, data frame. Then here guys, what I do, let me just pass in what data. That was a variable, I think. Yeah, that was the variable here at the top, where there are many data sets, there are many values here. Can finish to call up. Yeah, it's data, the variable. So what I do, let me just get here at the bottom, then let me pass in data, then here the print function, I'm gonna print that df. So let me say print and then I'm passing what df, and then what I do, let me run, and then guys, wow, there's an error, right? Let me check it out. Oh, sure, it has done what? Name error. Name error. Let me find the error. Can I find the error? Oh, guys, basically, the name null is not defined. The name null is not defined. Or perhaps there's null somewhere. Oh, here it is. The null. It should be deleted. Oh, basically, I have several null values here. I should have, cleaned. I should have, deleted. So, what do I do? Let me, in my data, let me just delete every rows that has null. Let me find where this null value and then delete so that it may not. Remember, when it is null, it should be inside the quotes to define that as a string. If you want to use it directly in these codes. However, if it's in a file, then it's good. But if you want to use it as a dictionary, then you have to specify. Yeah, here's the first null. And let me just delete. Let me delete here also. Let me delete there. Let me delete here also. Let me delete there. There are many nulls. I don't know if I've skipped some because there are many. Let me just try to run it again and see if it will work. So guys, you can see it has printed out the data. So guys, you can see it works. So basically this is how you can load the JSON is a Python dictionary, and you can see it printed out the results. So guys, I want to show you how you can analyze the data frames. So one of the most used method for getting a quick overview of the data frame is the head method. Now basically the head method returns the headers and specify the number of rows starting from the bottom. So for example, in this data, for example, if I want to return the heads, I can just say df, for example, df dot head. So guys, basically in this case, we can get a quickly overview by printing the first specify the number of rows. Like for example, let me give it. For example, I want to return 10 rows. I will just specify 10. Then I guess what, it has returned 10 rows. Remember, indexing begins from 0. That's why when it reaches 9. But remember, 0 is counted as 1. That's why you have 9 values here. So basically you can use the CSV files, but in this case, guys, you can see I've just used the JSON file. Or rather, guys, let me just find the CSV file, right? Let me just use the CSV files. I don't know if I can get here at the top. Let me just find where there was CSV. Yeah, here it is. Let me just use a CSV file. I think is best. You can do the same with the CSV file. So here you just specify the head property or a method, then you specify the number. Then when you run, it will return what, the first 10 rows. So if the numbers of rows is not specified, it will return the basically the head will return the first top 5 rows. If you don't specify if you don't specify these if you don't specify the numbers here, it will return the first 5. Like you can see, it is the first 5 rows. Remember, zeros like 1, 2, 3, 4, 5. Yeah, there are 5. So there's also called a tail method for viewing the last rows of the data frame. If I want to return the rows, the first last rows, you just use the tail method. Then when you run, it will return the last 5 rows. You can see 1, 2, 3, 4, 5. The last 5 rows. So also guys, you can specify the number in the days that you want to return. For example, if you specify, for example, 10 days run, it will return what the last 10 rows. Now, how do you obtain the information about the data? So basically, the data frames object has some method called info that gives you more information about your data sets. So in that case, guys, here the print function will add in this other method called info, and then remember you must always close info, and then what I do, let me run, and then you can see it gives you all the informations here. You can see here pandas.co data frame range is 169 entries, 0 to 168. Remember, indexing begins from 0. And then data columns total there are 4. And then you can see that's duration. Duration it's 169, and null values. So guys, basically I'll be using this data. I'll be modifying these data sets to have wrong values, so that we may understand how we can clean it. So first of all, let's begin. Let me do it. Let's begin with the empty cells, right? Let's begin with the cleaning empty cells. You can see we have the empty cell here. We also have the empty cells here. We also have the empty cell here, and many other cells are empty. So I want us to begin with the cleaning empty cells. So basically, remember that empty cells can potentially gives you wrong results when you try to analyze. So one way to deal with empty cells is to remove the rows and basically the rows that are contain the empty cells. So this is usually okay since data sets can be very big, and removing a few rows will not have a very big impact. Basically, let me show you guys that I want to show you that. Let's get back to our codes. Then here to this, guys, I want to return a new data frame with no empty cells. You can see, you can see here, guys. Let me just load these tabs here once again. Let me just return load these values, and then let's check it out and see if we have some non-value. Yeah, guys, you can see we have some null value. We have the cells that has no values at all. Like here also we have no values there. We also have no values here. So guys, I want us to return a new data frame with no empty cells. Now to do that, we have to let's say import pandas is a p or again basically the best way is just let me just copy these values because our codes are just the same. I think by now you understand how to use these codes. So don't waste a lot of time. Let me just use the same codes, and then now here I'm gonna add in a line of code here called, let me call it new underscore data frame using the snake case here. Then here let me assign it to data frame df, the alert for data frame, and then a dot drop now to drop null values here, null cells here. Then let me close, and then here the print function, I'm gonna print out the new underscore data frame df, and then here let me say dot because I want to return everything to underscore stream, but even if I don't specify it will still return everything. I don't know where is the problem. However, let me just run again and see. So guys, you will realize that some empty cells are no longer available here. First of all, let's check it out and find which cells had null values. from, you can see it's number 17 or number 18. There's a row number 18. Remember, indexing begin from 0. You can see 17 has no values here. They label 17. Let's find it here. You can see there's no 17. It is 16 and then 18. 16 and 18. There's no 17 because we have deleted what the row number 17. You can see. So this is a single way, or basically one way of cleaning empty cells, just by removing the entire rows that contains the empty cells. So remember, by default the drop method returns a new data frame and they will not change the the original. So if you want to change the original data frame, and then we have to use what the in place true argument. So guys, basically in that case, let me just do this. Let me copy. Let me use a new cell again, and then here at the drop now, I'm gonna use another method here. I'm gonna use here another argument called in place. In place, I'm gonna give it a true boolean or a true value, and then what I do, let me run again and see. I got an expected keyword in place. Oh, sure, guys. Basically, there's a problem here, guys. Right? It should be in place, right? I think there's an error, right? In place. I think it's just correct. I don't know the problem here. Oh, guys. Basically here, I should have done what I should have. Sorry, guys. I should have used here the drop now. Sorry, guys. I should have used here. Should have used it here. Then what I do, let me run. Oh, guys, basically what I do here, I forgot here, guys. Basically I forgot here. I should have just use this variable the way it is. Let me just, I should have modified here to a df. Then let me say dot to string to underscore string. I think this one will work. Let me pray it works. So embarrassing. Let me just try to run again and see if it will work. And then guys, let's check it out. So guys, basically this is how you can do it. This is how you can remove all the rows without the values. You can see previously, guys, I would just so guys, basically this is another way of how you can remove all the rows with null values. But this one, guys, if you want to, this one will also change the original the original values. So guys, basically remember now the drop now into in place underscore true will not return a new data frame, but will remove all the rows containing the null values from the original data frame. So guys, basically another option, guys, another option that you can do, another option that you can clean empty cells, or you can work with the empty cells is by filling it with another values. So another way, guys, of dealing with the empty cells, I said, is inserting a new values instead. So this way you do not have to delete entire rows just because of some empty cells. So we have another method called fill now, which allows you to replace empty cells with a value. Let me show you that, guys. Let me copy these codes. Let me copy the codes, and then let me just paste it here. And then here, guys, basically I can use fill method here. I can use df.fill. It should be fill now, and then here let me just specify the values. Perhaps let me call it 100. Let me give it 100, and then in place true. Then what I do, let me try to run, and then you can see now we have the row number 17, but now we have replaced the values with 100. You can see it is 100 now. It is not empty. So you can also replace the values that has, that values that has what, that has, you know empty space. You can fill with that default value or any values related to your data. Just an average. You use a value which will not have a very big impact in your analysis. So guys, basically, you can as well do it. You can as well replace only for specified columns. Remember, this example or this format, this one will replace all the empty cells in the whole data frame. That is empty. For example, if you have these other cells that has some values which are null, so when you use this method, it will replace all the columns. But you can as well do it. You can as well specify the columns that you want to replace. To replace only empty values for one column, you can specify the column number. So like guys, let me use or let me just use the same codes here. But then guys, in that case, you have to do it in this filter, in this df. You can do this. Let's add in this property. Let's add in this empty what, this empty open. It should be empty and opening the squared brackets, and then here you can pass in the column that you want to affect. For example, it is calories. You can specify calories, right? Calories. And then I think is a correct name. Remember, if you use a different name, it won't work. And then here, guys, I want to use a different values that will help you understand. Let me use a 1 a very big number that will help you distinguish. This one is a modified value, to make it stand out. So I want to let me run. And then now, guys, you can see now 17, it has a large number. So you also have 27. We also have 91 and so forth. So guys, basically this is how you can do it. This is how you can target specific columns to be modified. Now you can also replace using the mean, medium, or mode. So basically, a common way to replace empty cells is to calculate the mean, median, or mode value of the column, so that it may not have a very big impact in your what, in your output or in your analysis. So Pandas uses the mean, medium, and the mode methods to calculate the respective values for specified columns. So guys, basically in that case, you are going to do this. In that case, guys, you are going to, let me create another variable here. Let me just use a symbol like a x. Then let me say df, and then here I'm gonna do it. I'm gonna pass in the calories column, targeting calories is a string. Then here I'm gonna find the mean. So let me say dot mean. Dot mean method we used is a mean method, and then here guys, basically instead of these values, we are going to use the variable which has the mean, and then here when I run, it will be filled. Let's target number what, number 17. Let's be keen on number 17 and see the results. So what I do, let me run number 17, right? You can see it is now 375. So guys, basically this one is a very best way to fill these values with the mean. So remember, the mean is the average value, or the sum of all the values divided by the number of the number of values. Now the value in the middle, after you have sorted all the values, is what we call median. You can also replace with the median. So in that case, guys, you just in here to for median, guys, you just replace here to median, then it will replace with the median. Median is a central. Median is the middle value. You can say median, and then what I do, let me run. Then number 17, you can see now it is replaced with the median. Now for mode is a number which is repeated several times. Now for mode, guys, we just specify mode, just add in mode, mode. Then now, guys, basically for mode also you have to specify this index. You have to add in this 0 to add in and to specify the index. Then basically actually the column. Then what I do, let me run and see if it will work. And then at the mode, when you use this 0, it will target this single column for calories. And then for number 17, let's check number 17. You can see it is 300. 300 is the number which is repeated several times. So guys, basically this is how you can work with the empty cells. So guys, basically the best way here to clean this data, because I can see there are strings, there are values which are strings which are not convertible. You can't convert a string into an integer. So guys, basically the only option here is to do it if is to delete the entire rows that has these values which are awkward. It's just to delete the entire rows. And I showed you how you can do that using the drop now values, basically the drop now method to do that. And that's the only option. But if it were integers, you can convert either from a float to an integer, or an integer to a floating number, or to such stuffs. So let me talk about something else also, how you can fix the wrong data. So wrong data does not have to be empty space or a wrong format. It can just be a wrong, like someone registered, for example, 100 instead of 1000. So in your data, you can, or basically you can have data. You can see the range here is between can be between between the 100, I think 100 to 600 or so, but then you get a value which is something like 1 million. So guys, basically you can just tell that this one is a wrong data. So sometimes you can spot wrong data just by looking at the data sets, because you have an expectation of what it should be. So basically in that case, you'll have to do it. So guys, basically in that case, guys, basically you have to fix that. So I said it doesn't have to be wrong, but taking into consideration that this is data sets of someone's workout. There's no way that the calories can be 1 million. It can't be. So basically in that case, what we do, we can conclude that. If it's 1 million, you can just conclude that this one is a wrong data. So guys, basically how can we fix values like these ones, which are very very awkward, like I should have used here a different value. Let me just change here. Let me change some values so that you can relate what I'm talking about. Like so you can see others range between 100 to I think 600 or so. So what I do, let me just change here the first one, and then what I do, let me give it some huge values like this. Then let me save, and then let me save, and then what I do here, let me try to do it. Let me just try to run, and then as you can see, the calories here is 4. It is even I don't know it is 409 million. You can just tell that this one is a wrong value, because there's no way someone can have such huge values for calories. So basically guys, in that case, you'll have to do it. You'll have to replace these values. So how can we replace the values? So let me show you that, guys. Let me copy these values. Let me use here different cells, a different cell. Let me paste it here, and then guys, basically in this case, we have to modify here. Here the print function, guys, we have to use the log parameter. First of all, let me define the data frame. So df dot dot lock. Then let me target the index number. It is index number 0, right? It was index number 0, I guess. So in that case, you can specify index, basically the index number. For example, it is log, it is 0. I think it was 0, and then a comma, then the calories. I think it was the calories. I'm not sure. Calories. Then I want to give it some different values, like let me just give it 300, or let me give it 1000, so that you can distinguish, you can see the change. So here the print function we have to use to add in this other, to return the everything. Here we can use to underscore string a method. Then let's run and see if it will work. And then guys, you can see it's now 1000. So guys, basically another option is just do it, just replacing the values. In that case, basically guys, this another way of how you can do it. This how you can clean some values, or even dropping the entire. Another option is just dropping the entire rows in the, that how to drop. And then yeah, so you can also remove duplicates. Let's find out some duplicates, values. Duplicates are rows that have been registered more than once, like guys, I want to modify our data. Let me just use this one. Let me call it for example, let me give it, or let me change it to 110. Here also let me change it to 130, and then here okay guys, let me just give it counter. Let me give it 300. Let me give it 300. Also here, let me give it 300, so that they may have the same values. And then what to do always, let me save. So guys, you can see these values are duplicates. They are identical. So I want to show you how you can do it, how you can delete that. So I think I had saved. So let me get back to our codes. So guys, basically how do we clean such values? So guys, basically by taking a look on our test, basically in this test data, or basically this data of hours, you can just tell that 1 and 2, they are identical, or they are duplicates, and to discover duplicates, so we can use the duplicated method, and the duplicated method returns a boolean values for each row. So let me show you guys that. Let me show you that. First of all, let's be in our codes, and then let me copy these two lines of code, because I don't want to repeat the same stuff again. Let me copy, then let me do paste here. Then here the print function and say print, and then here I'm gonna pass in what? I'm gonna pass in df dot duplicated method. So guys, basically this method will help us to identify the duplicates in our data sets. So if it returns true for basically it will return true for every row that is duplicated. Otherwise, it will return what? It will return false. So let me check it out, and then should be print, right? Should be print. Then let me run, and then guys, you can see number 1 is duplicated. It's true. You can see number 1. Number 2, it is duplicated, and it's true. You can see this one is number 1 is just a duplicate of this one, you can see. And so guys, I think you understand that. So how can we clean it now that we have identified the duplicates? So guys, basically to do it, to clean it out, what we do, should I modify just one of these values, or let me just repeat it again so that everyone can understand. But first of all, let me just copy these codes. Then let me use it here at the bottom, and the new cell. And then here, guys, basically I'm gonna use let me say what? Let me just say df dot drop underscore duplicates and then we use this argument here in place. You give it what? A true value, a true, and then here the print function, guys, that we're gonna do what? Let's do this. Let's because this method will help us to identify the duplicated section. But here now I want to do what? I want to print it out. So let me say df dot to underscore string method, and then what I do, let me just run, and then guys, you can see now number 2 is now deleted. You can see it is now deleted, it's no longer available there. So guys, basically this the other way of removing the duplicates or cleaning the data that has the duplicate values. So guys, basically an extension to this course, I want to show you Pandas data correlations, and I will also show you the plotting. So guys, basically a great aspect of Pandas module is the core method, and the core method calculates the relationship between each column in your data sets. So in this example, guys, I have this. I will just use this sample data, data.csv, and I have some data here. Now I want to try to find what the correlation relationship, between what each column. So guys, basically let's try to do it. Let's try to find the relationship here. So basically I say that we use the correlationship. So now first of all, let me copy these 2 lines of code, because this is our data. And then here now, guys, basically to find the correlationship, here the print function print, we can do it. We can say df dot core. This method will give us the correlationship between the sets. Let me try to run and see if it will work out. And then I guess you can see it has given us this relationship. So guys, basically the results of this there's a core method, is a table, as you can tell, with a lot of number that represents how well the relationship is between two columns. So the number varies in the range of -1 to 1. It can't surpass 1. So let me try to tell you a bit about these relationships here. So if you have one value like this one, if you have 1, it will mean that there is a 1-to-1 relationship. That one is a perfect correlation. And for these data sets, each time the value went up in the first column, then the other one will go up as well. It is directly related. And then if you have 0.9, and do you have 0.9 here? I don't think so, but in case you hit 0.9, then that one is also a good relationship. So if you increase the one value, then the other one also will be affected, will be increased. And then also, guys, we have the negative 0.9. If you have that is negative 0.9, then this one is also a good relationship, but it will be the other way around. So if you increase one value, then the other one will go down. If you increase the other one, then the other one will go down. And then if you have perhaps 0.2 somewhere, and then that will mean that it's not a good relationship. meaning that if one value goes up, it does not mean that the other value will go up. So it is unpredictable, with the when you have a 0.2 correlation. So now, guys, basically, what is a good correlation? Now it depends on the use, basically on the use. But I think, guys, is good to say that if you have at least a 0.6 or a negative 0.6, you can call it a good, correlation. On my opinion. Now, perhaps let me just talk about these relationships in a few, the perfect, good, and the bad correlations. So guys, let me begin with the perfect correlation. And guys, you can see here, this one is a perfect correlation. It's 1-to-1, duration versus duration. And this one makes sense, like each column always has a perfect relationship with itself. But if you had some values which are perhaps 0.9 or something, it will tell you that it's a good relationship, and you can predict that the longer you work out, then the more calories you burn, or the other way around. And so then the bad correlation is the ones that have 0.2 and below. So guys, basically if correlation is like 0.009 or 0.008, then that one is a very very bad correlation, meaning that we cannot predict the max pulse by just looking at the duration of the workout, and vice versa. So guys, I think now you understand the correlation concept here. Now guys, basically as we finalize, let me show you how you can visualize your data. So not really to visualize or to plot. So Pandas uses the plot method to create diagrams from Matplotlib. So you can use a PyPlot as a submodule of the Matplotlib library to visualize the diagrams on the screen. So like guys, basically let's try to visualize this data set here, guys. Let me just copy. Remember, I already have Matplotlib here in my system. Now here, let me just say what. Let me just add in import another module. Now the good news with having an account environment, these modules are already available there. So Matplotlib. And guys, remember that Matplotlib, it must have the compiler to visualize, like it usually have the TK in there. So ensure, guys, that's why I recommend you to use the Anaconda environment. It usually comes with those packages. However, if you don't have, it won't work unless you install the GUI compiler for Matplotlib. So Matplotlib .pyplot and then there's a PLT alias PLT. And then this is our data, and then I want us to visualize. So let me say df dot plot, sorry, should be plot, plot. Then to visualize, we say plt dot dot show, plt dot show. Sure, let me try to run and see if it will return some values. Guys, you can see it does. Let me zoom out a bit. So guys, you can see we have visualized, but for you, I think it won't work if you don't have the it can work. I think it can work. However, guys, there's a good practice to use an Anaconda environment. It usually comes with these compilers for you. So guys, basically this is how you can visualize these stuffs. So you can also use different visualization concepts here, like even the scatter. By default it give you what? It give you these lines visualization, but you can as well use you can specify that you want the scatter plot with the kind argument, like the kind scatter. And so basically let me just show you that. Let me just show you that. So here guys, let me just copy the codes. Then here, let me just paste it here, and then I try to zoom in a bit. And then guys, basically here I'm gonna do this. Let me just say I'm gonna add in another parameter here called kind. kind, then I'm gonna use scatter. Scatter, the spelling for scatter. Then guys, here I'm gonna specify the x-axis. Let me give it perhaps duration. Duration is a string, right? Should be a string. Duration. And y, let me give it calories. Calories won't work, right? Because it has some values which are not good. However, let me just try. Let me just assign it to. I did not modify the calories section, so the visualization will not be good. So let me just give it calories. Calories, and there's nothing called the calories here. It's capital C, calories, like that. And then let's try to visualize. I don't think it will work better. However, let's just try and see if it will visualize our data here. So I think it won't work because guys, basically it won't bring a good result because we had some strings. Guys, you can see we have some strings, so I have to let me try to change to a different values, to a different thing. Like, let me use max pulse, right? Let me just use max pulse. I think this one is good. So let me change here to max pulse. I think this one is okay, and then let me run. And then guys, you can see this one is working perfectly. So guys, basically this is how you can do it. This is how you can visualize. So guys, basically you can as well try with the histogram and so forth. However, guys, this is what I wanted to show you. You can find the reference on the website. You can always find here the reference www.nemtech.com. You are going to find all the courses here free of charge. Then I think this one is here at the Python. This one is at the Python. Then you're going to have access to that course, free of charge. So guys, I really appreciate you for your time, and it has been nice to be your instructor today. And guys, please subscribe and like the video and also share it to your friends. Until next time, this is Nehemiah. Goodbye.